I write a compiler for a small imperative programming language. The compiler is already written in itself. So in the current stage of the compiler, I only use the features that are already implemented, but not everything is done yet. The one thing that is missing is, for example, error handling. So the compiler assumes that the source code is correct and doesn't contain any errors. And I'm trying to add basic error handling to different parts of the compiler. And now I would like to look into the parsing and to add more errors to the parsing pass. And the first thing that I will need, the tokenizer does not track the location of the tokens, so we need to add the location first. And somewhere I should have a type that is, do I have something like location? No. So I will scroll to the top again and somewhere here add new type in a location. It will be a record with two fields, the one being line and the another one is column. We have this token cursor, and I think that this is a good place to add the location to this data type. So cursor is basically the Alexa state. Because it is a location. Here we can initialize the cursor location, line and column to 1. Actually, this is current location always. I'm not sure whether I need two locations in the nodes itself, so I need the start and end locations. And I probably need something where I can track both of them. Let us add here the end location as well. So we have start location here, and we also add the end location. And this is an location too. That seems to work. Then we need the tokenizing function. So we have a function. The whole tokenizer is a state machine, and there is a table that is used for calculation of the next state. And for each character, an action is called, and this action evaluates the current state of character, and we need to find these actions. And here we actually have our cursor, and we modify the finish position of the cursor. And in the same place where we modify the finish position, we should also modify the location. So execute action. I wonder what this advance function actually does. It is used only once, and it calls this advance thing recursively. So let us just merge these functions because they are very small. So we read the token, and if the state is finish state, isn't finish state, then we call advance with the cursor. And I think that this token can be just replaced with cursor token. What Lex execute transition does. So as always, I will split my screen so I can look at two places simultaneously, and we'll look for this execute transition function. Transition. And it returns a token. So if it is not finished, this execute action just returns a nil. I'm not sure I have to assign this at all. But okay, the sense behind it is that now we assign this token variable to the cursor token. And it won't exit until we see the finish state, and then we can assign it here. Okay, whatever, we just keep it as is, I would say. So we do the transition. I think that this recursive call is not a good fit for here. What if I can replace it so it returns token only if we see the finish state as cursor state? Let me put a label here. And we execute this transition. If the state is not the finish state, then we go to the label. Otherwise, we assign this token to the cursor token. Okay. So it executes. Then we have this advanced function. This is actually the one that I wanted to have, advanced token. We rename it just to advanced, it isn't used anymore. The advanced token is used in itself, of course, but we just can remove it with a comment. I rename it once again. So now we get the cursor, and what do we need else? Actually, we do not need everything else. The cursor should point to the current character, that would be start. And what was it? It was this execute action. Execute action, and the one thing that this advanced function should do, it should implement the finish token, and it should implement then the end location, I think. So we can remove all of these block, actually all this stuff. And cursor and location column is +1. This is of course not true, because we should also increment the line and reset the column. I do not have a special special handling for the spaces. I think that I just keep them. So spaces should be this thing here actually, and it increments both the start and finish of the token, because the spaces are not meaningful in my language, but only outside of strings and stuff like this. And if I want to classify a token with a single character, then I use this is the one problem. Also my language cannot access single bytes, therefore I have this help function load byte that actually adds the current byte. So we can, for example, say current character, for example, and for the current character we use word. So I do not have a proper type checker, and therefore I use word if I do not know the type, or if it is a type that isn't current supported. Word is just a generic type that I use for different things, so something like a dynamic type. And we want actually to add, or we can just call it character, just like here, and then we can add the current character. So I say that character is load byte from the cursor start, and then and then we can compare it. Probably to track the start and end location I should, so I have 2 pointers to the source text, the start and end, and to track both locations, the start of the token and end of the token, I probably have to move the locations at the same time. I do not know how to do it better, so if this is a space, the start and finish pointers should actually point to the same location, so probably I do not need to do it twice. We will test it how it works. So now I have the current character, and I want to check if the current character is a new line. Then we set the cursor start. Do we move end location or start location? Let it be the end location for now. So we set the column to 1, and we increment the line number. Is actually the same. +1. Otherwise we increment only the column. If it is a space, I only have to implement the start location. If we start a new token, we should set the finish position, the end location to the start location. I can pass the needed location to this function as pointer if needed. Once again, so we have this skip action. It should be probably the only one where the start is incremented. Exactly. So an additional step that we do, we call this Alexa advance function. But we will have changed the arguments. So if we skip the spaces in the source code, then we need to increment the start position. So what we do, we pass not the whole cursor, but only a pointer to the start position. And we also need to pass the current character to this thing. I think I can just pass the cursor start to it. And probably before I increment the pointer. So classify single, we already have this case, and I call it start position. That would be the thing that we read the character from. So we pass the start position to this load byte function, and we say that its type is word, and the type of cursor, this is not cursor, this is a location, and the type of this location is a pointer to an ELNA location, and it does not return anything. So this can go. We do not increment this thing here, and we do not reference the cursor, but we reference the location. We need to dereference it before we can access the fields. And the same for here. And then we can check whether it works. It does not. Location. Start position is of course wrong, it is start location. Okay, this is the first case. Then we have a function that resets the token that is currently read, and this is probably this Alexa peak function, and reads the token and advances the Alexa. Okay. This is the read token actually, and I think that we do need to do the same with this location. So we finish a token basically by setting its start location to its finish location. This is the state before we read the actual token. Cursor start location. And now if we do not read the spaces, we need to advance the end location. So here we increment both, and I actually should also increment both locations. Do I know when I start a new token? Actually, I do, I think. The peak function checks whether the token was already read, and if it wasn't, it sets the state to the start state, and here we can set the location. So that the start location and end location start at the same point. I think this can be done easier. We can just always increment the end location, and if we start the state here, then we set the start location to the end location, and then we do not have this problem at all. So we will solve it a bit differently. Probably we do not need this copy here. We will move it to the Alexa peak function, but this advance function in Alexa advance. So yeah, exactly. We pass the cursor to it. And we advance the character is cursor start. We advance the cursor finish is cursor finish plus 1, and then we reference this one, this finish location, and cursor finish location column, line and column. These are not pointers, and here we do the same. And of course it is not a finish location. I use finish there because end is a keyword, but end location is of course not a keyword. So we have cursor end location here as well. Okay, this broke the compiler at other place, but in this case I know what is the problem. So execute action, it already does the finish thing, so we can remove this line from here. At other places I actually know that it is not a new line, so we do not have to check whether it's... I can just increment the location, the column. Okay, so it's not a problem after all. What is the problem then? Okay. This will fail. Let me remove this if statement. It still doesn't work. And what is about the load byte? This is the only... Oh, I have finish here, but it still doesn't work, I think. Oh no, now it compiles, okay. As I said, we can probably just create two functions. the one function will check whether this is a new line or not, and another function will just increment the column and the finish thing. So let us bring it back and just remove it from here, I would say. Then that should compile, I hope. Of course it doesn't. Okay, and I see my error already. So now we have this thing, and we will rename this, or we will copy this function just, and we will rename this one into classify space. Do I have any classify functions that take the whole cursor as argument? No, I do not. But well, we will call it classify space, and I have it here. And I will have a different function advance that will just increment the finish pointer in the cursor, and it will increment the column, so the else action. And this advance function we will call everywhere where we increment the finish pointer. So for example here, and here, and here, and here then too. I'm not sure I should call the advance after. After that. Yeah, I suppose it's fine. So this should compile. This should compile. So we have advance and classify space function, and I wanted to edit this function so it doesn't accept the cursor. yeah, just rewriting it again to the previous version. There we had start position, I think. So classify integer, for example, takes this start position, so start position as word, for example, and the second argument would be location pointer, and it would be an location. This is the location that we want to increment, and we would once again replace this location line and this stuff. Okay, now it is called, of course, a bit wrongly, but I think it is actually a different error. But as I said, we would call it cursor start here, and then what was it? It was the end location. So it was the end location, so we pass a pointer to the cursor's end location. And that would be the start position. And of course, since we increment the end location here, we can also increment the start location here, but we need to reset it then. Why do I increment the start pointer but the end location? Actually, I think it doesn't matter. Where do we have this memcpy? After we've read the token, we set the start location to the value of the end location. It is one possibility. And the another one would be to call this memcpy at a different place. So we always increment the end. We always increment the end location, no matter what. But if we start a new token, we need to set the start location to the position of the end location. And this is exactly what I do here. Okay, we leave it as is for now. Another thing, we need these locations now in the tokens itself. So I have a Lexer token here somewhere, and we also need 2 new fields in this record. Start location, end location, and end location, end location. why there is an error. I thought that I checked it. So we create tokens, then in this Elna-Lexa classify functions. And we set the token here. We set the position here, but not always, only if it is needed. But all tokens will get the location in the source text. That means that for the token creation, that means that these classify functions will need the cursor. Otherwise, I have to pass a lot of arguments to it to read the locations. Or I probably can create another type. Yeah, let us do it this way. We will create an additional type that we will call position. Elna position is a record, and this position has a start location. We can just call it start and finish, or whatever, start location and of type Elna location and end location of type Elna location. And instead of referencing this type, this start location and end location, again we will just use this this position type. So if we do it here, we won't need to change anything because we do not use this Elna-Lexa token. But if we change it in the cursor, then everything will break. Position. Okay. So we say that. Let us do it the same way. We set the position end location and position end location, and then we just call memcpy and we copy this thing into no, we just assign the values. So this is the one place. Here we pass the start location to memcpy as well. So we also write position here. And that's it. What I do not believe, we had this classify space as well, and it also gets it gets the end location. So position do we have end location anywhere else? For example, here as well, and here. And here. Position and location, start location. Okay, that looks fine as well. I think that the only function that generates token is actually this action function, because these classify functions, they complete the token creation. So we go above them, classify single, classify finalize. And then we have this composite the keyword string compare. It's an Alexa token create. And this function will get Alexa token. It will create a token and return it at the end. My classify functions do not have the cursor access, so this function won't get the cursor. We can actually pass the kind to it, for example. So we can write it in one line. Kind is Elena Alexa kind, and we pass a pointer to the token positioning. In here, then we can set result kind to Alexa no nonsense to the kind, and we copy the position to the result position from the given position, and the size is the size of the Elena position. Okay, so and then we begin here. We add an additional parameter, position, Elena position, and this isn't probably with the first function, but okay. So we create an additional parameter, and then instead of malloc we call this an Alexa token create function, and we pass the kind to it, and we pass the position to it, and that should be enough to create this token. position is a pointer, but result position is of course not a pointer. So we have to take the address, but we still have some problem here. And if I remove this line, oh, of course, position is of course garbage. So we go to the Alexa classify integer here, and we add the cursor position to it. Exactly. The next function, let us do this one, delimited, classify delimited, and we also add an additional argument to it. Can I just copy it from here? So this position, delimited, we add this position argument, and that means that I do not set any kind. Oh, this is something I haven't thought about. So I set kind later in this conditional check. Alexa token create, we create a token and we pass the kind and the position. Let us begin with this comment and then position. And what we basically do, we assign these fields later, and in this if condition we assign not the kind but the result itself. In the first case it is a comment, in the second case it is a character, and here it is a string. Then we move to the next function, the next one. So we have delimited integer keyword. So we pass the position to it, and here's the same, we just okay, this isn't helpful. We just create an identifier and then we remove the else case at the end. And it still doesn't work. Okay, at least this one seems to compile. We create the result with the kind, and the default kind is the identifier if it is not a known keyword. But if I remove this else block, oh, now it compiles. So then we have classify composite. Then we have classify composite. We add the position to it. And this is a bit more interesting. We do not assign positions, not the positions, but this start and length of the token. So it is Elna Lexa token create. And the first one is, for example, this thing, and the second one is the position. And we can replace now these results with it. Here it should actually work with a bit of luck. Then we have not equal here. Then we have greater equal. So, and then we have an arrow. Please don't crash. Okay. So classify composite, and then this classify single, it doesn't have an else case. So is this the next function? Composite finalizes the next. Then we only have the single function actually. Yeah. So classify finalize. We can copy the position argument from here. And we can pass it to this function then, so basically here. And now I just say that result is Elna Lexa token create. This is the type and position. Here we do have a dot, then we have left parent. Then we have minus. Then we have less than. And then we have greater than. Now we can remove the first allocation and test it once again. And the last one in our list is the classify single function. And we add also the current position to this function. It was somewhere here. And now it has a few if-else cases as well. Result is an Alexa token create, and the token kind is semicolon, and position is its argument. And now we can remove this line. So here we have comma, then we have right parent, then we have add and not and end. Plus multiplication equals reminder division and dot head and square brackets. And that's it. Now we have a tokenizer that can track the position of a token in the source code, and we save these token positions in the created tokens, and I can use them later during the parsing.